Everyone, welcome back. Today I am going to teach you graphical representation of motion. In that we are going to study these two things. One is your distance time graph and one is your velocity time graph. Let's start with distance time graph. So here you have two tables. One axis it is representing time and one axis which is representing distance. By simply seeing this table you cannot determine or you cannot interpret this data. And in case if you have large number of data points, then it is very difficult to determine anything from table. So it is best to represent this thing from graphically. From graph you can direct analyze that, you can tell many things about this data. So let's do it. So here is your table that we are going to represent. So here's the graph. So if you see, in the x-axis what you have is time, in the y-axis what you have is distance, and it is uniformly distributed. What you have to do is, for 1 second 5 meter you have to draw like this. You have to draw. So draw two perpendicular lines, 5 meter 1 second. So you will get 1 point like this. You have to draw all points. When you do this, what you will get and join them, you will get a straight line. This straight line is representing uniform motion of the body. Uniform motion means this body or this object is moving with constant speed or same speed throughout. Now let's draw next data. So for 1 second it is 2 like that. So for 1 second 2 somewhat here, then for 2 second 3 somewhat here like this. If I put these points and join them, what I will get is curve like this. So you can see what this curve, it represents non-uniform motion. So in distance time graph, when you get straight line like this red one, it represents uniform motion. Any type of curve like this yellow one, any type, not only this, will tell you about non-uniform motion of the body. Other than uniform and non-uniform motion, let's say if you have line like this, which is parallel to x-axis. So this line parallel to x-axis, that means at 1 second body is at 15 meter, it's 2 second body is at 15 meter. That means with change in time there is no change in position of the body. That means body is at the rest. So from this graph what you can say is you have three type of data. One is this, which is uniform motion data. One is this yellow one which is non-uniform data, and one is this, which means data is this object is at rest. Now from distance time graph you can also determine velocity. How to do it? Let's say you have this graph from last table, and what you have to do first thing is to draw perpendicular line for each and every marked point like this. Now take any 2 points from this data points. I am taking this one and this one. Now let's say this is your, because this y-axis is representing distance, so let's say this is your d2 and this point, this is your d1. Similarly this point here, it is your t2 and this point here is t1. Now what is velocity or speed? It is distance divided by time. So I can write velocity is equal to distance d2 minus d1 divided by t2 minus t1. So if you do this, 15 minus 10 and 3 minus 2. So 15 minus 10 and 3 minus 2. So what you will get is, if you solve this, what you will get is 5. So 5 meter per second is your velocity. So like this, by taking any 2 point, you can find out velocity from this graph. Now so far what we have done is distance time graph. Now let's say we have to draw velocity time graph for uniform motion. That means what you have to do now is, instead of writing displacement on y-axis, you have to represent velocity there. So let's say this is my graph where instead I have time on the x-axis, same I have time on the x-axis, but on y-axis instead of distance what I have is velocity. Now what I have to do is just opposite of what we have done earlier. I have to find distance from this uniform motion graph. I'm already telling you this is uniform motion graph. That means same speed throughout. So you are going to get like this. Now to find distance, choose any 2 points on time axis. Let's say you have to find distance traveled by a body when it is moving from time t1 to t2. So you can choose any 2 points. So how to choose? Draw perpendicular line. So like this, I am drawing two perpendicular lines. So you have to find distance traveled by a body when it is from time t1, that is 2, to time t2, that is 5. So how to do it? So let's say this is your t1 time and this is your t2 time. So here in the velocity time graph, this area of rectangle, this rectangle, this will give you distance. So area of rectangle is length into breadth. So this is your length, which is nothing but 4, and breadth, that is this t2 minus t1, which is 5 minus 2. So when you solve this, what you will get is 12 meter. So from velocity time graph, you can find distance. From distance time graph, you can find velocity. Just go through the slides once more. Try to understand this. I will give you some data